Hello, let's start potential today. What is this picture? This is a container having water. If I pour water into this container, its level of water gradually rises up. That means what? If I pour water, the amount of water is equivalent to charge, and its height rises up as you pour water into it. Consider it like this: as you give charge to a body, its potential gradually increases. That means if you compare amount of water to charge, compare height to the potential. So adding charge means rise in potential. First idea. Second idea, application of this. This is a picture. In this picture, there are two tubes, one very thin, another a little wider. Motu badlu. Anyway, now water in this is only one mug, but its height is more. And here, suppose 3 buckets of water has been poured, but its height is less due to its wider area. Now, can you tell me, if I remove this valve, then which direction this water flow takes place between them? Yes, obviously from this to that. And due to this, its height will gradually increase and its height will lower. So time will come when this will reach this height and this will reach this height. Roughly, don't go about the exact amount. So their heights will be same. Time will come and then its height decreases, its height rises. So after a certain time, their heights would be equal. So we can say that there is a charge distribution. Come to charge now. There is a charge distribution between two bodies in such a way that when two are connected together, the body which has got higher potential, it has got higher height, means what? Compare this to higher potential. And it has got less height, H2, compare this to lower potential. So we can see charge flows from higher potential to lower potential, and the flow of charge continues till both reach to a common potential, equal potential. We will go in detail of this in next part, capacitance. Remember, this is the basic idea. So V1, that means its height, greater than V2, that means its height. So charge will flow, that means water flows from V1 to V2, H1 to H2 height. So that was second idea. Now, as we have gathered some idea, let's come to official ideas, bookish. Potential is defined by, so its definition is given by work done in bringing a unit positive charge from infinity to a point in a region. So combining these, work done in bringing a unit positive charge from infinity to a region is called potential at that particular point of that region. So that is the definition of V. You have been doing this since, I suppose, from your class 8, 9, 10, like this. So we will quickly move on to this formula. W equals to QV. Work done in bringing a unit positive charge, that is one charge, is V, potential. So work done in bringing one charge is V, work done in bringing Q charge will be Q times of V, that is Q into V. So that is work done is given. But one idea is that here V is actually delta V. That means delta V means change in potential. Change in potential means it should always be V final minus V initial. Suppose we are bringing a charge from point 1 to point 2 like this. So work done in doing that would be the charge that we are bringing is suppose Q into V final. It has been finally brought, see the arrow, it has been finally brought to point 2. So V final is V2 minus V initial. Initial it was having a potential V1. That is the meaning of this. I think you got it. Next, work done is this much. Okay, remember this work done does not depend on what? On path. That means if I bring the charge from 1 point to 2 point following this path, the work done would be same. If I bring the charge following this path, that would be the same work done if I bring the charge following this path. It doesn't depend on path. That is another important idea. Third important idea about the definition is that potential should have a dimension, and its dimension would be given by, use this formula, W equals to QV. W equals to QV. So V would be given by W by Q. So its dimension would be dimension of work done by dimension of Q. I think you know this. Dimension of work done is ml square T to the power minus 2 divided by dimension of Q. I had told you at the beginning of this chapter, dimension of Q is at shortcut. So it is m L square T to the power minus 3 A inverse. That is the dimension of potential.